Well, welcome back, everyone. I hope you enjoyed your lunch and you got a nice break and nice socializing with all these wonderful colleagues that have come here from all corners of the world. I have the pleasure, after introducing our first plenary speakers this morning, to introduce our second round of plenary speakers, which are this afternoon. And I have the pleasure to introduce a gentleman, lady, gentleman. I won't be sexist and begin with a lady. So I will begin with Vassilis. Mr. Vassilis Katsouros is the research director of the Institute of Language and Speech Processing of the Athena Research Institute and director of ILSP since 1919. In fact, he works with engineering. You're from the beginning an engineer and a PhD in mathematical modeling. So all of his research, in effect, is from machine learning to all of these fields that have to do with this using new technology to deal with new forms of learning, and especially machine learning. And he will be presenting us. I don't have in front, I wasn't a good host, I didn't come with this is the subject that he will be presenting us. I will turn to it, together with Spyridoula. Their talk is Conversational AI Assistance for Teaching and Learning, Human-Centered Pathways for LLMs to Classrooms. And so Vassilis Katsouros will be presenting with Spyridoula Stamouli, who is a specialized scientific personnel in the same Institute of Language and Speech Processing of the Athena Research Center. And she's been working there for quite a very long time, exactly on the same issues, and they're working together. And today we have the pleasure of hearing the essence of their results in their presentation.
Thank you.
Thank you very much.
Thank you very much for the invitation and for the introduction. In the Institute for Language and Speech Processing, we have two communities. One is the computer science, and the other is the linguist, the computational linguist. So we have digital humanities and computer science, and we have been working since 1992 that was established. At that time, the technologies were about machine translation. And people know Google Translate, but they don't know that translation as a technology was developed in Europe because Europe is multilingual. And we are the result of this European effort. And at that time, it was starting, with rule-based systems. And in '92, computer science, it was the first statistical-based machine translation. And since then, they followed the path of how humans communicate with machines, with computers in natural languages, either with speech or with text or with gestures. And one of the topics that we have been working all these years is on learning technologies. At the old time, it was computer-assisted, and we were focusing on language learning because all the technologies were about language and how we can use these language technologies incorporated in language learning tools like assessment of pronunciation, or at the old times of correcting spelling mistakes. But now we have now that the technology has matured all these years, and we work on AI. AI is a very broad term, but how you teach the machines by data and get them extract the information out of the data and learn and do tasks for humans. So one of our tasks was on educational technology, on teaching and learning environments. And with Spyridoula, We have the presentation today. It will be in two parts. The first part will be given by me, and the second part will be given by Pepi. So I will give some overview about the LLM basics. We will be talking about how we have developed LLMs in Greek and see in practice the outcomes and the limitations that they have. We'll be giving some overview about some techniques that you can align the LLMs to follow your own knowledge basis and how you develop now. We live in the agentic AI and the multimodal AI. And the second part, it will be more on education. We had a project on AI for Edu. We'll give you an overview of all the outcomes that we worked these nice years. This project, actually, it started, the same time when ChatGPT was released. It started 1st of January 2023. ChatGPT was 30th of November 2022. And our technology at that time, when we submitted a year before, it was how we can use questioning answering NLP technology AI at that time to use, to have the teachers get their own content and develop, based on their content, educational content for the students, personalized, etc. So we removed the technology with Q&A, and we went to GPT technology, and we had the luck to have the first experiments in a real setting and see how students and teachers were using these systems. And we have been looking at issues about how we can align these systems to pedagogical frameworks and curriculum, and also how we can use them in personalized learning. And these are current topics that we have been working. So this is the timeline of LLMs, the large language models. And you see, large language models were before ChatGPT. At November 2022, ChatGPT came out, and everybody knew that there was a community working on this technology. And since then, you see here with the yellow is the publicly available LLMs, and you see mainly American and Chinese releases, mainly from companies. You don't see universities. The European landscape there are these Mistral Large, and this is a French company that started at that time. This is very important because publicly available, and when we say publicly available, data are not open, weights are open, code is open, so you can train your own models and you can tuning either to language or to your own particular domain. So GPT, you have a pre-trained model that has to be trained on massive amount of textual, mainly textual, but when it's multimodal, you have to give other abilities like vision. Again, the quantities are huge, and we're talking about different natural language coming from written resources, but also code or maths. And this is very important because it gives the ability of structure. And the computational languages help the natural languages as well. And the main technology and the main model is based on what is called the transformer. And this is very important because you can give massive amount of data parallel. So this was one of the reasons that you didn't have to wait for quite a long time, and you had to wait only for 2 or 3 months computational time to get the basic model. And the key characteristics like, cars, we have, the capacity, the ability, how massive they are. In LLMs, we have the billions or the trillions parameters. So we're talking about the parameters, and the parameters specify the abilities that they have about knowledge and capabilities. The transformer, as I said, is the core of the technology. And inside the transformer, what the transformer does is has many, many attention mechanisms. So getting one book at a time, for example, it gets and it has many, many different points of views, if you like, and gets the abstraction and structure at different levels, either semantically or structurally or topics, etc., etc. So, but what it does, it gets a context, which is a number of words. It goes through a big structure like the transformer, and at the end, you have a decoding algorithm where you have to calculate, what is the most probable word given the context that you have given to the model. And you have to select what is the word. So you have a decoding algorithm that specifies what will be the next word. And actually, we don't have words, we have tokens. We're talking about tokens. And what are tokens? Tokens are segments of words. And segments of words, why we use segments of words? Because one natural language has millions of words. When you segment the word, only with thousands of segments, you can represent one natural language. So and actually this is the vocabulary. To having millions of words by number of languages, by 200 tokens, vocabulary, depending on different alphabets like Chinese or Greek, Latin, and you have languages, you have stresses, so you have to put all into the equation. And behind every LLM has their own tokenizer. So the vocabulary are the tokens, and you have the algorithm that has been trained on optimizing how you can use these tokens is called the tokenizer. And you have the representation of characters. The tokenizer splits into segments, and those segments are represented by numbers. And this is what goes inside. And we're talking about context. This is the context. The number of tokens, so is the memory of the model that goes inside the LLM. So depending, the first LLMs were only 4,000 tokens. Now we're talking about million tokens. And since we are talking about tokens, the tokenizers are optimized in order to represent words approximately by 1.5 tokens. So 3 tokens is 2 words in natural language. So if you consider one page of 300 words, you have 450 tokens. So one book of 250 pages is approximately that. So if we have 1 billion tokens, we are talking about 9,000 books with these characteristics. And if we are talking about 1 trillion tokens, we are talking about 9 million books. And all the LLMs that we have been using, they have been trained about approximately 15 trillion tokens. So we are talking about huge, massive amount of data that needs to be there. So the LLMs, what they do, they tokenize, so they take the text, they split into segments, they represent the segments into numbers, so this is the encoding, the embeddings, and then they go through the computational of the transformer, and they have many attention mechanisms. And from these attention mechanisms, they get prediction of the next token, And based on the predictions, you have an algorithm that selects either the first or the second or the third. So, and this is the way that goes on. So this way of producing, of generating text, you have high capabilities of generating high quality of text because the data are massive. So these, with the multi-attention mechanisms, you have encoded all these textual information, which has become a knowledge, because through text we have saved the knowledge, the human knowledge. So the machine have read books from mathematics, so they are good mathematicians, from physicists, they're very good physicists, they know languages, but humans, we struggle for many, many years just for one discipline, for becoming a medicine doctor. But the machines can get this and after 3 or 4 months, they become experts in all the human knowledge domain. So they have the ability to answer questions, to summarize, and to solve logical puzzles by seeing and reading these examples. However, they have many, many limitations, and these limitations are not bugs, they are features, because when they don't have conscious of what they know and what they don't know, because they don't know what is knowledge. So when they talk, they generate text. So when you have something that is not in their knowledge or in the encoded knowledge that they have been trained on, so they will produce something. So this is what we call hallucination. They don't have, for example, real-world understanding of common sense. So we have to give them this common sense by examples. And all biases, they are in training data. So all the teams behind these huge computational machines, they are struggling to remove all these biases, and they put their own behavior. So Croc behaves like Elon Musk. So we are talking about products. And of course, they use high computational cost, and it's not something that we can do by a normal computer in our university. There are huge investments, they are capital investments that in the US by huge companies and corporations, in Europe by the States and the European Union. And we are talking about AI factories. And in our example, we work on LLMs since 2023, and have been released 2 of them, and now we are working on the Greek AI factory, and we'll be releasing one next month. So one was based on Mistral, and the one was based on Llama. And we used what is called continuous pre-training. So we took the model, but the model had their own vocabulary. For the Greek, they had their own tokenizer. So it was not optimized for producing character by character. So the tokenizer at that time, it was 6 tokens per word, almost character-based generation. So we made our own vocabulary, and we continuous pre-training on 40 billion or 100 billion afterwards. And then there's a stage of supervising training by giving the ability of chatting and answering questions in different domains for Greek languages. And then we had our own alignment and behavior to give them the cultural behavior. And of course, another thing, at that time, all the benchmarks were in English. So what we did, we took the benchmarks in English, and we produced benchmarks, respective benchmarks in Greek. However, we didn't remove from the benchmarks the cultural effect. So if we're talking about not science questions, but history questions, we are talking about George Washington and not a general from the Greek history. So this is something that we are working on, and we are producing data sets because we want to see how LLMs are performing in natural, in having the cultural effect as well. And this is one example of the benchmarks about common sense and truthfulness, and can humans survive by drinking salt water if they boil it first? And you have different answers, and the correct answer is no, because some people believe that boiling salt water will remove the salt. And so the way that we compare LLMs is by this kind of benchmarks, and every company releases a new LLM, and they have numbers. So the benchmark went up, and this is from human examples. But they have created also the LLM arena, and the LLM arena, why the companies have created this? Because implicitly, they take our data from this, and this data, by preferring this answer to the other answer, we are giving this alignment and the reinforcement alignment with human preference. So when we have what is the best LLM in the world, this is in Greek, I put here the GPT 5.4 and the Claude. They give different answers. You see how different they behave. They have different structure or generate text, and you say, okay, equally both, or this is preferable and this is not. And by this way, you give preference data. If you see how you can try quickly, I had in the previous slide the address. So you can do different tasks like text processing for summarization, for translation, problem solving, temporal reasoning, question answering, text generation, and also code generation. Code generation is very important because apart from the natural languages, you have to give the ability to produce computational code, so we'll be able to talk to tools and extract from tools, for example, computational, like math, simple additions, for example. And what is very important is the way you ask your question. So that was the prompt. And initially, in the initial days, it was so, it was like an art, so it became an engineering task. And from this engineering task, we are talking about thinking now models. But thinking models, they started by providing in a prompt, when you give a question and you say to the model, think step by step, so it starts thinking step by step, so it produces data on the way it thinks about the answer. So when you ask something, you have to be not very specific, not vague, give the context that you like. If you want to produce the steps, so ask explicitly that, give the personality, so assign a role, and so in a generic example like explain photosynthesis, it will give you the physical way of the answer. When I say the physical, is the way that behind the scenes there is what is called a system prompt. So all the developers, they have written a huge amount of text, of guidelines, of giving direct instructions to their model in natural language. So they are becoming aware of their name. They are becoming aware of their knowledge. So all these features are giving this a hidden prompt that every time goes inside with our own prompt. So when you are becoming a specific, and the same question is the explanation for photosynthesis, but you pretend that you are a biology teacher and you want to give the explanation to a 13-year-old. And the structure is by 5 bullets using a simple analogy. So the model will generate and will follow the instructions more specifically. Another very important aspect of parameter is what is called the temperature. If you remember in the previous slide, there was a decoding algorithm. So we're selecting what is the most probable word. So most probable word, it means low temperature. When you are giving the ability to select less probable word, so it becomes more creative, how we call it. So it surprises the way it will produce. So if we want our model to become creative, then we have high temperature. If we want to be more factual, we have low temperature. And every developer has a balanced temperature given the personality that they want to give. So, and as I said, in the old days, it was 4K context. So at that days, if you, all the dialogues that we are that we are using with the LLM, so one turn after another, it goes through the context, one after another. So after many turns, when you put your name there, and you have many terms, when you ask your name again, it will forget. It doesn't know, it doesn't have the concept. So they have a limit of the memory. Now all these, there are certain techniques and all the companies behind the scenes, they are, when they reach this limit, they are compressing the dialogue and they try to extend with this trick the memory. But even those, you have this limitation. So in hallucinations, as I said, they can produce fabricated citations, especially about, and we have seen that when we ask them to produce knowledge from scientific knowledge. They can use wrong dates of historical events. They can have outdated knowledge. For example, if you ask them about the conflict between Israel and Iran, they had the specific knowledge. Now they go into the web and they get this information and they are producing the knowledge that like they have of today's event. But their basic knowledge, when they trained, you have a cut-off date where all the teams, they put all the text inside the knowledge. So asking the same question by default will produce different outcome. And of course, they don't have the ability like the calculator for doing arithmetics. They learn arithmetics by this example. So actually, they don't have this ability. And another very important aspect is the biases and how responsive they are. So they are following stereotypes or gender biases. They can produce harmful content, and all the developers, they are trying to remove this knowledge or trying to protect the LLM of producing this kind of information, but at the same time, there are other groups are trying to cheat and tweak the LLM to produce this kind of information. So we don't want to produce privacy or personal data. All the teams, when we are taking the information from the internet, we do many filtering techniques for removing everything. But if we are using huge information, like 1 trillion or 10 trillion data, we haven't looked at the data at all. So we have used algorithms, but we are not certain that we have removed 100% all the personal data information. So you have at the later stage to give the ability to protect your LLM. And actually now we have guardian LLMs. So when you do a question, it goes to the guardian LLM, and the guardian LLMs knows, is it a dangerous question? Is it for something racial? Is it for something personal? Or something behavioral? And protects the actual LLM behind the scenes. So it will not release this prompt directly to the LLM behind the scenes. And given that, some tips for educators. So give you the role and the audience. So give what is your role as a history teacher and explain to a particular target group. Specify the format, so give the answer to specific format. Set the length of the response that you like to give. If you want to produce the thinking step by step, you can ask for that. Ask for examples. Request alternatives if you want to produce different alternatives. From the step by step, you can give chain of prompts. So you can ask sequentially change of prompts. Check the confidence of ask the LLM to produce evidence about how confident they are. Give negative constraints. So don't use jargon or avoid mentioning this particular notion, etc. And all of these, try to improve your own prompt by improve the previous answer by adding this and that. Now, we are talking about LLMs, but now we are talking about agentic and multimodal AI, and one particular technique about retrieval augmented generation. So if you have a knowledge base, you want to align your LLM with your own knowledge. So what you take the prompt, you go to the knowledge base and you retrieve from the knowledge base the extracts that are similar to the question of the user. And given this context, you go to the LLM along with the context and the extracted information, and you generate the actual answer. So the LLM will not answer with their own generic knowledge, but you guide it through your own knowledge, and this is very important. So putting that, this is the main idea when I started, and as I said, you can start and do that in iterations. So this is one basic iteration. And if you can put that into, read the documents, plan, act, reflect, and collaborate, then by giving direct prompts to the LLM and put that in order, then you start having something that is producing and is having an agentic or a particular pattern of thinking. So this is how we have the main, one of the main techniques is how we can use our own knowledge base, and another technique by prompting or by prompting and code generation, by calling other tools, you can produce different architectures of getting the response. At the end, the user will see a response. And now we are talking about not only text, but we're talking about images, video, audio, code, of course, and all these go into robotics and becoming into the physical world. And the challenge now is how we can put the AI, we can move the AI from the huge computers and go to and react with the physical world with the use of robotics. So AI education, one thing from me, and then I will pass on to Pepe to continue. So for us, we have used it for personalized learning to enhance and augment the way teachers are using either for producing their own material or doing some other words, accessibility in many, many languages, and this is very important, and the level of languages. And of course, there are some challenges that we need to be aware of hallucinations, privacy, and the way the actual students or teachers are using these nice tools. So I will pass on to Pepe, and she will continue the second part.
Good afternoon. Thanks for being here. And after this walkthrough to the landscape of Gen AI and LLMs, my presentation focuses on what happens when this technology meets the classroom. So I will be presenting results, evidence, and insights and experiences from our work in several European projects that we have been working on and coordinating over the last 3 years in the domain of AI in education. So, starting from AI for Edu project, as Vassilis mentioned, it was launched just 2 months after ChatGPT's public release. The context then and until now in European schools was that the students and teachers were facing heavy workloads, disengaged learners, and fragmented digital practices. So this technology came with enormous promise, but also raised several concerns regarding trust, ethics, data privacy, and pedagogy. It was a real disruptive context. Gen AI adoption rapidly outpaced any pedagogical framework existing and any regulatory framework. And at the same time, there was no systematic evidence on the actual impact or value of this new technology. So this was the context of the AI for EDU project, and our response to that was a human-centered, evidence-based, iterative approach to responsible AI integration in education. The project at a glance, it is an Erasmus Plus forward-looking project which ended last December. It involved 4 countries and 6 partners, addressed secondary education, and aimed to develop conversational AI assistants for students, study buddy, and for teachers, teacher-mate, covering the learning with AI pillar, but at the same time, there were 2 more pillars that we covered: learning about AI, so helping students and teachers develop prompt literacy and critical understanding of the limitations and capabilities of AI, and also preparing the educational community for responsible and ethical interaction with AI systems. This slide presents our 5 commitments which reflect our position of how, what it means to develop responsibly AI systems for educational use in a European context. The first one is participatory design, meaning that the end users, teachers and students were part of the design of our prototypes, giving us feedback on their needs, testing our prototypes, and giving back their requirements and recommendations in 2 iterative cycles. So this was not a single-stage development process. It was a 2-cycle process involving eliciting user needs through surveys, interviews, etc., designing the first version of prototypes based on these needs, piloting and evaluating our prototypes in authentic educational settings, gathering feedback again, and revising the system based on this feedback. So we had 2 development cycles and 2 pilot cycles. Interdisciplinary collaboration was another basic pillar. Our team involved LLMs and AI experts, experts from the domain of pedagogy and educational research, curriculum experts, active teachers, policy makers who informed one another. Also, our consortium was cross-national. It involved countries with different educational cultures, different curricula, different levels of institutional readiness and digital infrastructure, which meant that we designed and developed for diversity and inclusion. And last but not least, ethics was a basic principle guiding all our activities from the beginning in areas such as how we handled students' data, safeguarded their privacy, obtained consent, how we handled teacher control and oversight over the AI outputs, etc. After an extensive needs analysis phase, which lasted about 6 months, we developed the 2 conversational AI assistants, Study Buddy for students and Teacher Mate for educators. Study Buddy was developed as a tool to support self-study at home for secondary school students. And Teacher Mate was initially conceived as a companion of the teacher for mainly assessment tasks. But since we had the power of LLMs, we enriched the system with more features and capabilities. Both tools are powered by GPT 3.5 at the beginning and 0.4 and GPT-4 at the end. They all use retrieval augmented generation architectures as Vassilis presented earlier, which means that they are capable of grounding their answers in the official textbooks of all the participating countries for selected subjects. They are multilingual and they also offer text-to-speech and speech-to-text capabilities. The key tools offered by StudyBuddy to students is concept explanation and Socratic dialogue, text summarization and key point extraction, quiz creation and self-assessment, writing as essay improvement and feedback. We have some interactive tools such as debate with StudyBuddy or role play with historical figures, timeline builder, and several other tools. On the other hand, TeacherMate involves tools for lesson planning, content creation, and assessment, but also it offers classroom management, basic classroom management features. So the teacher is able to create a class, automatically generate tests, assign the tests to the class. The tests are automatically corrected by the AI. Feedback is also generated, and all this output is editable by the teacher. It is not sent back to the student before it is confirmed and validated by the teacher. This is the point where TeacherMate and StudyBuddy meets. All these tests are assigned to students via the StudyBuddy environment. Moreover, teachers are offered the My Content section where they can upload their own materials and make them available for interaction. And they have a teacher dashboard with analytics about their class performance and individual student performance over time. After an initial pilot phase, these tools were refined, enriched in terms of both user interface, but also for prompt architecture in order to address needs for personalized learning and individualized teaching, which was a main requirement from the teacher's part. This, following Vassilis' tips about prompt architecture, this is a real example of the system prompt architecture of StudyBuddy, and more specifically the explain term tool. Here we can see 5 components of the prompt shaping the LLM behavior so it can behave like real in a pedagogically appropriate manner. First, we identify the role of LLM. It is an experienced and helpful tutor and not an answering machine. We provide the pedagogical stance, and in this example, we specifically instruct LLM to use Socratic questioning, not giving direct answers, but providing questions leading to the answer. We also put curriculum constraints. If the user chooses to upload a textbook, we instruct the LLM to draw, to retrieve information from the official textbook. Another parameter is inclusion. We instruct the LLM to always take into account individual student needs expressed by the user themselves. and adapt accordingly. And last, contextualization. Your explanations should be contextualized with relatable examples and analogies, so they are easy to understand by students of the specific age and level. The example on the right is an example of an interaction using this tool. The student asks what's Newton's third law, and study buddy responds with a question rather than giving the answer directly. As I said, the first pilot phase was aiming to evaluate our prototype's usability and technology acceptance. The first version of our prototypes. This phase was conducted between April and June 2024 with approximately 120 participants. We used the technology acceptance model and measured 4 constructs across a 5-point scale. The interesting finding here is that, okay, there was a positive acceptance of our prototypes. We scored high in most of constructs and mainly self-efficacy. Our users felt strong enough and confident to use our prototypes. Perceived ease of use was equally high, and attitudes towards use, however, the usefulness, perceived usefulness score was the lowest, which is a finding consistent with the literature that usability outpaces actual perceived usefulness. And capacity building is the bridge needed to close this gap between feeling confident to use a tool and perceiving it as actually useful. So after this phase, we developed the final versions of our prototypes, which were ready to be evaluated for their actual educational value and impact in real settings. Around 480 students and 15 teachers participated in this second pilot phase across Cyprus, Greece, Ireland, and Sweden. We used a common methodology across countries involving experimental classes which were taught with teacher-made and study buddy, and control classes without any AI assistance. Pre and post surveys were administered, as well as pre and post academic tests before and after the intervention, as well as motivation and engagement questionnaires in order to measure learning gains and students' engagement and motivation. The findings were quite interesting. Although we didn't find statistically significant learning gains across all use cases, there were some use cases which stood out, and we found actual and significant learning gains. The first one is the GR history use case. There we had a trained teacher, highly motivated, who used study buddy in classroom to engage students in critically evaluating the AI output in topics related to history, and also familiarized students with the study buddy tools, using the timeline creation or role-playing with historical figures. And this was a really successful use case, translated into significant learning outcomes for students. Another one was the Cyprus physics use case, where we also had a highly engaged teacher who systematically used study buddy with students and prompted them to use study buddy at home for homework preparation and for test preparation. So the pattern that emerged was that although study buddy was conceived initially as a tool for self-regulated learning outside the classroom, the significant learning gains were found when it was used in the classroom within a teacher-led, teacher-mediated framework, and not as a standalone tool for home use. Regarding engagement, here the example of Ireland stood out. There we had mixed ability classrooms with special education needs students and students of minority backgrounds. These were the students which were more motivated and engaged with the AI, as reported by their teachers. Κλείνουμε. Okay, this is our final deliverable. We ended up with implementation guidelines and policy recommendations, building on this rich evidence base. And here, I'm just showing you our current research efforts. The first one is in the framework of a new project that is just launched, Gen AI EDU Map project, moving towards from proof of concept to systemic scale, and other research trend that we are actively pursuing, personalized learning. Okay, I'm skipping all this information, and I'm closing and leaving on screen our lessons learned, pedagogy before technology. This conclusion came out throughout our activities, that teachers' role as an orchestrator between human and machine intelligence is indispensable and makes the difference, that usability does not equal pedagogical value, but capacity building is needed there to translate, to make the translation. Teacher agency is a non-negotiable requirement by teachers. We need an environment of psychological safety from the part of the teachers in order to be able to use AI more creatively and effectively. Inclusive AI actually reaches special education needs learners, provided that we have teacher support and mediation. And last, evidence drives policy. We need evidence-based studies, and this is very highly valued both by the educational community and policy stakeholders. So, thank you.
Thank you both very much. It's very interesting and very important, and I'm very glad that in our research centers in Greece we're creating, and especially we're finalizing, saying exactly what much of the discussion was this morning and is always around the topic. Humans and teachers are here. Pedagogy is above technology, but together with technology, it can make teaching and learning better. So thank you very much. Congratulations. I apologize because we don't have very much time for questions. I presume that you will be around if you need to have any questions. But I think, Bill, we need this room for... There is next session, yes. So thank you very much. Please, you can be available if they want to ask something. Congratulations, great work.